Good afternoon. My name is Paul Haycock and I'm from SUEZ Water Technologies, specialising in water purification systems for laboratory applications. Welcome to episode 4 of our webinar series, where we are aiming to answer all of your frequently asked questions around purified water and its applications. This episode is called Water Purification Technologies and will take around 15 minutes, with another 5 minutes at the end for any questions. You can submit questions by the chat function at the bottom of the webinar screen. Future episodes of our webinars will focus on the advanced technologies used in water purification processes, different water systems, and how to maintain them. If you have any other questions about purified water, please send me an email and we will cover these in one of our webinars. Laboratory water purifier. Here you can see the flow diagram of a typical ultra-pure water system that is used in a laboratory, which shows the pre-treatment, reverse osmosis membrane, polishing cartridge, UV sanitizer, and ultramicron filter. Water purification using reverse osmosis will require some form of pre-treatment and, depending on the water quality, post-treatment after the reverse osmosis module. A laboratory water purifier will have a pre-treatment filter or cartridge and a polishing cartridge after the reverse osmosis module. In addition to this, and depending on the required water quality, the unit may well have a UV chamber and an ultramicron filter. Central purified water plants. Here is a typical central water plant layout, which will have a similar pre and post filtration, just on a larger scale. The drawing here shows the pre-filters, water softener, carbon vessel, reverse osmosis unit, polishing cylinders, UV chamber, and the ultramicron filters. What is a pre-filter? A pre-filter is designed to remove particulate matter, i.e. dirt and sediment, from the water prior to further treatment. Generally, a pre-treatment package will start with some form of pre-filter, or sometimes referred to as depth filters, to remove any large particles in the water. This helps prevent any blockages to mechanical parts further along the system. The filters required would normally be specified depending on the supply water quality. Normal potable water will use either a 5 or a 10 micron filter. The filters are made from spun bonded fibres and come in various lengths. For laboratory water purifiers, the depth filter will be part of the pre-filter cartridge makeup. Within a larger central system, it would normally be in a filter bowl. The pre-filter cartridge or filters in the filter bowl will normally be a disposable filter, so a routine will need to be in place to change these on a regular basis, normally every 2 to 3 months. What is water softening? Although not commonly used on a laboratory purifier, a water softener can be found on a central system. The water softener works using a process called ion exchange, which uses an ion exchange resin. The resin comprises of tiny polymeric beads, which are specially formulated so that they can be charged with sodium ions. The calcium and magnesium ions found in hard water are the 2 main causes of limescale. By using ion exchange water softeners, you can swap the calcium and magnesium ions found in the water for small amounts of sodium, which is a far more soluble element that doesn't cause scale. As water passes through the water softener, it moves through the ion exchange resin bed that is charged with sodium ions. The calcium and magnesium ions in the water swap places with the sodium ions on the resin bed, which produces soft water. This process continues until all the sodium ions on the resin bed have been exchanged. At this point, the resin gets regenerated by being flushed with sodium solution, or brine as it's commonly called, which in turn recharges the bed with sodium ions. Depending on the type of reverse osmosis unit following from the pre-filters, the water may pass through a water softener. This is to prevent buildup of scale on the RO membrane, as scale on the membrane will reduce the production of the purified water. What is activated carbon? After the water softener, an activated carbon filter or exchange cylinder will be used to remove chlorine from the water. Activated carbon is a form of carbon that is being processed to increase its surface area by the use of steam, high pressures, or chemical treatments. The main use of carbon in water purification is to remove chlorine from the water, as over time, chlorine will damage the RO membrane surface. Damage to the membrane surface will result in poor rejection of salts by the membrane. Due to its surface area and extensive pore structure, activated carbon will also eliminate tastes, odours, and remove colour, as in organics, from the water. What is deionised water? Deionised water is water that has had all or most of the ions removed. Ions are substances naturally present in water and need to be filtered out to produce pure water. Common ions like calcium, magnesium, sodium will often be picked up as water runs through the soil. Iron and copper can also be picked up as water runs through the water pipes. There are two forms of deionisation: ion exchange or electrodeionisation. Ion exchange is a deionisation process where water is passed through beds of ion exchange beads. When the water comes in contact with these beads, the ions are transferred from the water to the beads. This creates the final product of pure water. EDI, or electrodeionisation, is a form of water treatment that utilises electricity, ion exchange membranes, and ion exchange resin to remove ions from the water. Chambers are filled with ion exchange resin and separated by ion exchange membranes. And when the water passes through these chambers, the ions in the water are pushed through these membranes and the exchange resin by an electrical current. This then purifies the water. The most commonly used is ion exchange in the form of a disposable filter or regenerable cylinder. Electrodeionisation has been available for many years, but was considered considerably more expensive, although this has changed and become far more available and cost effective. What is UV irradiation? UV irradiation is a process of removing bacteria from water and has been used for many years. UV germicidal lamps are designed to emit the most effective wavelength of UV radiation, measured in nanometers. There are two types of lamps, a 185 nanome and a 254 nanome. The 254 lamp effectively stops the bacteria from multiplying and the 185 lamp produces ozone in the water, which is a natural disinfectant. We mainly use a UV lamp that emits a UV light at 254 nanohm. This is to prevent the rapid increase of bacteria in the purified water distribution loop. A typical UV lamp will have a life of 6,000 to 8,000 hours and will sometimes have a monitor to warn the user if the lamp fails. What is water polishing? Water polishing is a term used to describe the continual recirculation of the treated water through the system to keep the water at the quality that it's designed for, or its specification. After production of the pure water, if it is stored, it will slowly degrade and fall outside our required quality. To maintain the water quality, we continue to, or periodically, recirculate the water back through our dye cartridge or cylinder, the UV chamber and the UMF filter. This will ensure we maintain a high purity water in the system. What is the difference between microfilter and ultramicrofilter? The main difference between a microfilter and an ultramicron filter is the pore size of the membrane used. A micron filter membrane has a pore size of 0.1 micron, and an ultramicron filter has a pore size of 0.001 micron. A microfilter will remove bacteria, microorganisms, and sediment. An ultramicron filter will remove all the contaminants that a microfilter will remove, plus it will remove endotoxins, proteins, and some viruses. Its main function in water purification is to remove the bacteria from the water. By using an ultramicron filter, more contaminants can be removed due to its finer membrane. That brings us to the end of episode 4. I hope you've enjoyed the webinar and that I've answered lots of your questions that you may have had. Does anyone have any final questions that I can help with? The resin bed in a water softener, the manufacturers state that it will last between 5 to 7 years, but that is all depending on the quality of water that is coming into the water softener. So if you have an area that has high chlorine levels and it has high hardness, you might find that the water softener resin will not last as long. Somewhere that is a softer water coming into it and has low chlorine levels may last a lot longer. Typically in the UK, typically in the UK, the water in London is very hard and has a lot of chlorine. We would typically see resin lasting between 3 to 4 years. Somewhere like Manchester in the UK, the water's soft and the chlorine level's not so high. We may get 7 to 10 years from the resin in that area. It's all dependent on what the water's being fed with. Hi, Laszlo. Generally, the way that we build our systems, we will have the water softener first and the AC carbon afterwards. The reason being is we try to keep the chlorine in the water for as long as we can to reduce the bacteria, because obviously the chlorine will kill any bacteria in the water. So we keep the chlorine in to reduce the bacteria count before it gets to the RO unit. So we typically have the water softener first and the AC carbon afterwards. I can understand what you're probably thinking, that if we put the AC before the water softener, we're protecting the water softener. But obviously, we're opening up then that we've taken the chlorine out, and we may be breeding some form of bacteria in the water softener. So we like to keep our carbon after the water softener and directly before the reverse osmosis unit. The carbon filter lifetime. The carbon filter, if it's a disposable filter, we would always advise to change it every 3 months. If it's in a small cylinder, we would advise that to be changed between 3 and 6 months. If it's in a backwashable cylinder, which we will move on in one of our later webinars, we will cover backwashable cylinders. That one, we would measure the chlorine content before and after the carbon cylinder. And once we see that the carbon is not being as effective, we would advise our customer to change the carbon. But on smaller systems, that's probably not cost effective to do that. So we advise to change the carbon cylinder every 3 months. UV lights, manufacturers of the UV lights that we use stipulate to us that the UV light has a 6,000 to 8,000 hours of operation. Now, with a UV light, one thing that we don't want to be doing with a UV light is turning the UV light on and off. Every time you turn a UV light on, basically you take 1 hour from the life of the UV light. So we typically keep the UV light emitted all the time that the unit's on. The manufacturer says 6,000 hours. Our units have a timer in at 8,000 hours, and they will tell you that the UV light needs changing. A lot of manufacturers do stick hour meters on there, and they also stick a monitor on there to measure the UV intensity. So if the UV lamp starts to fail on its intensity, then it will warn you that the UV lamp needs changing. Well, thank you very much. If that's all the questions. Thank you for your time today, and we hope you join us for the next episode 5, where we'll be covering more advanced water purification technologies and going more in depth into reverse osmosis, deionization, and electrodeionization. If there's anything we can help you with, please do get in touch, and thank you very much for your attendance today.